Okay, today we're going to look at lesson 16. We're starting unit 3, which is over linear systems, and this comes from section 3.1, and your learning objective is I can solve systems of equations by graphing. Now, as usual, I'm going to move faster in the video than I would in person, so feel free to pause and rewind as you need to. You should have your notebooks ready to take some notes and then answer the Edpuzzle questions. All right, since we are starting a new unit, we do have a little bit of vocabulary to go over, so we're going to start there. Okay, so here's our vocabulary. We do have quite a bit of vocabulary, but it's very important. You could have some questions in Math Excel that require you to come back to these definitions and choose an answer. So, as always, get your notebook, write these definitions down, write the examples down the best you can. All right, so first we have system of linear equations. That's when you have two or more linear equations. So far, we've just worked with one equation at a time. Now we're going to look at two equations at a time, and we could see 3, 4, and so on. And our main focus for now is just going to be two equations. Then we have solution of a system of linear equations. We have to be specific with what kind of solution we're talking about, because the solution could be different depending on if you're looking at systems or an equation or an inequality. All right, so a solution of a system is any ordered pair that makes all equations in a system true. So you'll have an x coordinate and a y coordinate, and they have to work in every equation, not just one. You have some different types of systems. The first type is consistent. So a consistent system is one that has at least one solution. So that means it could have one solution or it could have many. If a system is independent, it has exactly one solution. That means there's one x value, one y value, one ordered pair that works for both. On the graph, you'll see that the two lines intersect at one point. Okay, so that would be independent if you graph them and they intersect at one point. The other type of consistent system is dependent. If it's dependent, there's infinitely many solutions. When you solve it algebraically, you could get something like this. You could see x equals x, y equals y, 0 equals 0, 5 equals 5. All of those are true statements, okay? And when you get that, that means that it's the exact same line. So if you were to graph it on a coordinate plane, you'd see that the lines overlap at every point. The answer that you would write down if you were solving algebraically would be infinite solutions, okay? So independent, there's one intersection, your answer is an ordered pair. Dependent, it's the exact same line, they're infinite solutions. The last type of system is inconsistent, okay? That's the opposite of consistent. And that means it's a system with no solution. So if you're solving algebraically, you might see something like 0 equals 5, or negative 2 equals 2, or 1 equals 3. Those are not true sentences. Those are not equal. So that means that there's no solution, and that's what you would write down. Now, when you're solving those by graphing, you're going to see two parallel lines, because the solution of a system is where they intersect. And so if they don't intersect, there's no solution. All right, now, like I said, these vocabulary terms are going to be important, especially your different types of solutions. You have to know when your answer is an ordered pair, when it's infinite, and when it's no. Okay, same with your graphs. You need to know what those graphs look like. Okay, the next thing we need to talk about is solving systems of equations. So there are some different ways that you can solve systems, and you can use any of the methods to solve any of the types of problems that you're given. But sometimes a problem is set up so that a certain method is easier than others. So here's a little hint. I really recommend that you write this down because you're going to need it, okay? So if you have two equations that are y equals, okay, like they might be in slope-intercept form, and those are just examples. Like here, y equals 3x minus 6 and y equals 2x minus 8. Those are both in y equals form. So the easiest thing to do here would either be graphing or set them equal to each other and solve. Okay, so those are the two methods that would be easiest when your problem looks like this or your system looks like this. If both of your equations are in standard form, okay, here's some examples. 2x minus 8y equals 14, x plus 3y equals 12. If they're both in standard form, elimination is the easiest to solve them algebraically. Then, if you have one in standard form and one is in slope-intercept form, or you have a y equals, or even if you have an x equals, okay, and here's an example, 3x plus 2y equals 5, and you could be given y equals 3x plus 2, or you could be given an x equals, either one of those. You wouldn't have them both at the same time with the standard form, but you could have one or the other. All right. The easiest method for that is substitution, because you're going to take whatever that variable equals and plug it in. So you can solve by graphing, set them equal to each other through elimination or substitution. And each method is going to be easier depending on what your problem is set up to look like. Okay. Today, in this lesson 16, we're just going to focus on graphing systems. So we're going to save substitution and elimination for later, and the setting equal to and solve. We're going to save those for later, and we're just going to do some graphing today. Okay, so like I said, we're just focusing on solving systems by graphing today. So here are some steps to help you do that. Step 1, you're going to graph the first equation, and step 2, you're going to graph the second equation. Now, depending on what your equations look like, you can do that a couple different ways. So I made some little notes over here to the side. And actually, let me draw a little line there to help separate that. So if they're in slope-intercept form, you're going to graph your B on the y-axis, it's up and down. Then from that point, you're going to use your slope to make a second point. So for example, if your slope was 2/3, you would go up 2 over 3. If your slope was 5, you would go up 5 over 1. If it was -7, you would go down 7 over 1. Okay, you've been practicing that. You did that back in Unit 2. So that should be review for you. If it's in standard form, you won't have many of these where you're asked to graph it in standard form, but just in case you ever stumble upon that, maybe on the ACT or something, I don't know, you will see them in Math Excel. But we're going to practice them just in case you see them again later. So for that, you do AX equals C and solve for X. You do the BY equals C and solve for Y. And then you graph those intercepts on the X and Y axis and make your line. Again, you've done that before, so that's review. All right. Number 3, your solution is the point where they intersect. So if wherever your lines intersect, you should have an X value and a Y value. It's an ordered pair. That is your solution. So that's what you're looking for when you graph them, that intersection point. If there's no intersection, your answer is no solution. And if it's the exact same line, you have infinite solutions. Okay, now let's practice what we just went over on some actual graphs. And I know that you don't have this graph paper in front of you in your notebook, so watch what I do, and you're going to do the same thing in Math Excel, okay? Or you can sketch out some graphs. You can Google some graph paper and print it out and do it on your own, whatever you want to do. But at least watch me work through these and see the process. So I'm going to use 2 different colors so that you can see exactly what I'm doing for each line on the graph. Okay, so I'm going to use this tan color for my first one. So I have y equals x minus 7. So my B is -7. So I'm going to go to the y-axis and I'm going to make a point at -7. My M is 1 over 1, because I can throw a 1 there. So from this point, I'm going to go up 1 over 1. And I'm going to do it one more time, up 1 over 1. Okay, I'm going to use those 3 dots to make a line. All right. You can make as many dots on the graph as you need to to make sure you get your line correct. All right. My next one, I'm going to use this gray color. My y-intercept is 3, so I'm going to go to 3 on the y-axis and make a point. My slope is -1, so I'm going to go down 1 over 1. So down 1 over 1. I'm going to keep doing it a few times because what should happen is that I run into the other line, and that happened. Okay, so I will connect these to make a line. And I'm looking for the intersection. So do my lines intersect? Yes, they intersect at this point. So let me get the coordinates. So that's 5, -2. So 5, -2 would be my answer there. Right, now we're going to do the exact same thing for number 2. So my B is -8. So I'm going to go to -8 on the y-axis. My slope is 5 over 1. So I'm going to go up 5 and over 1. And I'll do it again, just to make sure my line's straight. Okay. Now my second one, my y-intercept is 8. So I'm going to go to +8. And my slope is -3. So it's -3 over 1. So I'm going to go down 3 over 1. Down 3 over 1. And they do run into each other. So I will make a line. I want that point where they intersect. And so my coordinates are 2, 2. And that's my solution. Right? So you're following the exact same process over and over again. All right, let's look at number 3. So number 3, our intercept is -3. My slope is -1/3. So I'm going to go down 1 over 3. And I'll do it again a couple times. And you can even go backwards. You can do the opposite. So instead of going down 1, right 3, you can go up 1, left 3. Okay, and you can keep doing that to make your line. Okay, with my next one, my intercept is 2, and my slope is -2 over 1. So I'm going to go to +2. I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. And those do intersect. And the ordered pair is 3, -4. Right, number 4. Number 4, this one's a little bit different. It's not in slope intercept form, so we're going to have to do a little bit of work to get our line. All right, so I'm going to start with this first one. I'm going to do all my work in this color so you know it matches. So for x, I'm going to have x equals -9. And for y, I'm going to have -3y equals -9. So y equals 3. Okay, so I'm going to go to -9 on the x. I'm going to go to +3 on the y and make my line. Right? My second one, I'm going to do the same way. So I'm going to have 2x equals -4. So x equals -2. And I'm going to have y equals -4. All right, so I'm going to go to -4 on the y. I'm going to go to -2 on the x. And so I'm just trying to make sure my line is nice and straight there. All right. So this time, this one's a little bit different. They didn't intersect on a point that I was making with the gray or the tan. So they do still intersect, and it's right here. So I have to make a new point there. All right. And so what are the coordinates there? -3, 2. Okay. All right. Number 5, we're going to do the same way. They're in standard form. So let's start with the first one. To get x, I'm going to cover up y. And so I have x equals -6. For y, I'm going to cover up x. So 2y equals -6. Y equals -3. So I'm going to go to -6 on the x. I'm going to go to -3 on the y. And make a line. Okay. Now I'm going to do the same thing with the second one. All right, I'll cover up y, and I have 4x equals 4. And I'm going to come up here and do it. 4x equals 4. So x equals 1. And cover up x, so I get y equals 4. So I'll go to 4 on the y. And make my line. Again, I don't already have a point made where they intersect, so I have to make one. It looks like they intersect right here. And our ordered pair is 2, -4. Now, the last one is a little bit different. We're given x equals 4 and y equals -2. So when you're given x equals, that's going to be a vertical line. And when you're given y equals, it's going to be horizontal. Okay? So let's do the x equals 4 first. We're going to go to 4 on the x-axis, and you're just going to make a vertical line. So it's just going to go straight up and down right on that grid line. Y equals -2. We're going to go to -2 on the y-axis, and we're going to make a horizontal line, again, right on that grid line. And where do those lines intersect? At this point. So 4, -2. And what do you notice about the numbers you're given? You're given x equals 4 and y equals -2. So you're told what your x value is and what your y value is. So those go straight into your ordered pair. So x is 4, y is -2. All right, so those are all of your examples. Use those to help you with your Math Excel work. As always, if you need help, please let me know. Tell me in a Google Meet, send me an email, or hit that Ask My Instructor button. And have a great day.